Okie dokie. This is attempt 2 at starting day 7 because it was a bit of a boring stream when I'm just there reading documentation. In one of the previous streams, I came across the fact I needed an input function, and I initially wanted to make that input function, a function, so that the struct owns some function. So when you create your struct, you can give it any function you like as the input. And ran into all sorts of generics problems, having to fiddle with stuff around, and I decided not to in the end, and ended up just giving it this concrete get user input. And so when we go to run a function, run an instruction, I still called it store. It shouldn't really be called store. We grab our input from get user input. That's fine. That was fine for when we needed it. However, here we have 5 Encode computers in a row, and each Encode computer has 2 inputs. It's going to call input twice, and the first time it's going to be some face setting, some number, and the second time is going to be the output from the previous one. Now this is going to be a massive pain to try and do by hand. Typing each value in, not happening. So we need to go back and change this get user input to something more helpful. What I want to do is make it a closure, because some function type. Because if we give it some function type, we can give it a closure, which can capture the data and then deal with it. So in this case, we have just demonstrating a function that accepts a mutable reference to something that implements the trait fn mute, and it will return a usize. So this is the closure here. This is the function type here. It takes no arguments and it returns a usize. So we're looking for some type that implements that. We're going to use a mutable reference. The reason we're going to be using a mutable reference is I want to call this function multiple times with one set of values. So up here, create a vector, create a closure, which is just going to take this vector, pop a value off. That gives us an option and unwrap it. If we added a 4th line here, it would panic because we'd have run out of stuff. In this case, I'm choosing to move the vector in. Here, it doesn't really make a difference, except that v is no longer available after this. If I didn't move it, v would be unavailable from the beginning of this line to the end of this line, and then I'd be able to look at it again. In this case, it's fine. And we're just going to pop each one off every time we call this accepts function with our refmute func. So this accepts func, this is kind of like our struct, and it's going to take in this closure. Now that's great, except that in a struct, as it turns out, there are a few things we could do. We could use generics, but actually it's going to be much easier to use dynamic dispatch. So we're going to use some dynamic object that implements this to be determined at runtime. So what this is saying is this is going to be a pointer. It's going to be 2 pointers. The first pointer is to the object, and the second pointer is to a vtable to go look up the methods that need to be runnable. This is going to do some funky things, which we'll get to in a moment. But let's go and add it in. This can stay where it is for now. I really should have collapsed all of these. It's going to make life quite a lot easier. Also going to make life a bit easier. No, I'm going to need new. So previously we had derived debug, partial EQ, and EQ on incom. We don't actually need the EQ. We don't need it here either. We can get rid of it. And that's going to make life. Oh, we did need it there. Okay. Needs to be there. It doesn't, however, need to be in incom. And that's going to make life a little bit easier later. So let's go give it an input type, which is going to be fn mute. And the reason it needs to be an fn mute is because it's going to change its internal data. If I were being sensible, I would give it a return type of an option string instead. But for now, we're just going to give it a string. And we'll hope that whatever's implementing it is not going to run out of things. The reason it needs to be a string is if we go and look at our get user input, we are returning a string to go directly into our memory bank. Cool, so we have a warning already. Nice. DIN-FM mute string does not implement debug, and we cannot automatically derive debug. Now we need debug, we also need partial EQ. Debug will allow us to print it in outputs, it's very useful to have. Partial EQ is going to allow us to compare different structs, which is useful for our tests. So we will need now to go into implementing derive manually. So where we want to implement a trait, we give it, let's use standard IO, CMP, IO, and format. Where we want to implement a trait, we put the trait name and then the struct name, like that. Right, so the docs for debug is we have one method, a format, which takes self, it takes a formatter and returns a result. I'm actually going to modify these slightly. I'm going to call that format, and the format module has its own result alias, which is what this is and what it's actually going to return. Don't need you. And really what I want to do is a normal debug but without our boxed in fun move. We don't really need to see it, it's not that important. Unfortunately there's a relatively easy way of doing that, so we're going to take the formatter we've got and we're going to do, it has a helper method called debug struct, we'll give it the name in comp. And we're going to do a field, and we'll do memory, self-memory. And you can basically put anything here that will implement debug itself. And we'll do the output store. And then we'll finish. And that was it. That was, that's a format. So far so good. Now, binary operation double equals cannot be applied to type boxed in thing, which is going to happen down in our test. So that's fine. Now we just need to import partial EQ, which is in format compare for incomp. And that has it has one required method, which is equals. That then provides not equals. So we can call not equals. All we need to actually implement is equals, which takes ourself, it takes some other, which is type right hand sized, and by default right hand side is the same type as left hand side, so we don't need to bother specifying the type, and it's going to return bool. Equal is going to take a ref self, it's going to take an other, which is a ref self with a capital S, because that's the shorthand for our derived type. And all we're going to do is we're going to compare the top three. So self memory is other memory and self instructor pointer is other. Yeah, so that is fine. Oh yeah, that was silly. It's not format compare. It's compare partial equals. Okay, and now it's. Oh, we don't need to derive U anymore. Cool. So far so good, and that wasn't particularly painful. Mostly because a lot of the pain was off camera. So now we need to change our constructors. So from string, really this needs to be changed, but it's going to be an input, which is boxed in fun mute, turns a string. And then we're just going to give that input. And then on run instruction, instead of getting our input from this, we're going to do self.input. No, thank you. And we're going to call it. And it's going to complain, and it's going to say, there's no method named input for a mutual reference. To call it, surround the field with parentheses. So we're going to say this thing is a function, please call it. And that box will automatically dereference. So far so good, we've still got a lot of red. So now our getUserInput could go away. I'm going to leave it there in case I want it to be a user. In fact, let's make it a public function, and then let's make it a public function which returns a string. And the reason for that will be made apparent later. You need to be an unwrapped. Whole bunch of panics possible to happen here. And now we need to go fix our test. So our new int comp is going to do it in line. Box new some closure that returns empty string. And this is going to be the same. Box new some closure empty string. It probably would have been useful to make it an option and just put none in for the tests, but that would have been a bit painful. And that is it. I can actually now run this test if I wanted to. We create a new test comp. We would need to hijack the... in fact, let's do it. So let's do this first. Let's just see what happens if we do cargo test int comp. Failed to compile. This is failing because of day 5. Yes, it is. So we need to actually go fix day 5. We're going to give you a box new, and we're going to give you int comp. Okay, that's happy, and I will grab the same thing. And this is why I made it a public function, so that day 5 behavior is completely unchanged. Just because it will make life slightly faster. Cool, so I'll test the passing. Let's say that int comp input is yeah, that's fine. We're going to give it an input instruction, and we are going to, let's make some other value, let's make it 0. I need to go and check the instructions, but it looks like it's doing the right thing. So we need to check that you're at 0. The actual value it's going to change is, so it's going to look for the memory in position 4. So I think you should be doing this. 0, 1, 2, 3, 4, which is 33. Okay, let's just double check that that fails if I get it wrong. It does, perfect. So now we have modified our computer type so that it can take this inputter, which means in day 7 we could do something like let inputs is a vec of 0 and 4 or whatever. This is going to be dynamically created. Let inputter is going to be box new on some closure that is going to take ownership of the inputs, and it's going to do inputs pop unwrap. And then we can create our int comp. And then it's going to be back like 1, 3, whatever to string, and inputter. And now that means that when we run this, we need to make sure our inputter is going to have the correct number of inputs for the program we expect, but otherwise we don't need to interact with it. And of course we can generate this whole thing on the fly. So we create amplifier number 1, take the output, create a new set of inputs, create a new computer with that inputter. That's going to be the plan. Ooh, so that was a whistle-stop tour over giving our computer a function type. The other option, by the way, was to make a computer which is generic over some type t, and t is going to be some fun fmu that returns a string, where we give it f, input is of type t. And that would have been fine, and we could have done something like import comp fn run. It's going to take a reference to self and return a string, and it's going to do self.input. And again, as a field access, I'd need to do this. This impl needs to be generic over t as well. And this is where we specify what type t is. And this is one of the ways you can do type state in Rust. You can say, well, actually, it's going to be a subset. So in this case, it is fnmu. That's true. What don't you like? The problem with this is that if I go down to my test module and I go test computer, new comp is equal to a comp where, what did I call it? Input. Where input is going to be some closure, and all it's going to do, in fact, let's do the same thing we did before. Let mute v back, and I'm going to give it 2 values, 0 to string and 3 to string. No reason why. And it's going to be v pop unwrap. Assert equals comp dot run. Not going to be that at all. It's going to be the string. 3 to string. Well, that's awkward that now works. I am just going to let's go back to what we had before. Yeah, let's get a dot. Let's get rid of test computer for a moment. You need to exist, and you need to go. Come on, GPG. Sounds like the stream might be a bit longer. This is awkward. Hopefully GPG has woken up now. Come on. Ugh. Cool. So if we create an alternate day 7, disappear, that's fine. And we say that incomp is going to have an input of type T, where T is an FN mute, returns a string. Going to impl over T on incomp, where T is an FN mute, returns a string. Going to return an incomp of type T. Going to return an incomp of type T. Going to take an input of type T and give it an input of T. You are unhappy because this function also generic over T. Do I need to redefine the T? Why did I delete what I just did? Yeah, no, I think it should be fine. What don't you like? I think this might be related to the issue I was having before. What does cargo build think? That's in day 5, that's fine. Okay, here. Okay. Right, okay, fine. Yes, and you're not that, you are inputter. Just me being dumb. Right, sweet. So we can do that, and then if we go down to our tests, and I make input, I think is what I called it, some closure that's going to return 0. String. So now this function needs to be generic over some type T, and it's going to return an incomp T, where T is an FM mute, and returns a string. And here we go. Right. Every closure has a distinct type, and so could not always match the caller chosen type. So, even though T is of type FN mute string, if I created 2 different closures, which are FN mute string, underneath, Rust will give them 2 different opaque types. Those docs are here, where you see them doing something very similar. So they are returning 2 things that return an implet fn i32, i32, and tries to put them in the same vector, but they have different underlying types. A unique opaque type, where we cannot see the details and we can't guess it. That's the problem. Which is why I ended up going for the box trait. Now, why this was fine for the previous computer struct and not this one, I don't know exactly. But at some point I might find out. But for now, let's check out day 7 again. Fine. Test using normal generics. And I might go back to that branch at some point. There we are, that's it.